So we have a nice problem here which will really improve our understanding of how charges get distributed when they come in contact with each other, and then what is the consequent force or the electrostatic force between them when the charge redistribution takes place. So the question here is that you have two charges. One is charge Q1 and other is charge Q2, and in fact it's given that the charge on both particles is the same. So let us say the charge is Q and they both repel each other with a certain force F, and we can therefore label the force vector here as F, in which case this force vector should be minus F. Now another neutral sphere which is brought near charge Q1. So you have another charge 3 which is held by a wooden handle so that the charge does not leak out of sphere 3 when it gets charged, and right now it's neutral and it is touched with charge Q1. So this is 1, and obviously there's a redistribution of charge between 1 and 3, and once this happens, charge 3, which now has a certain charge, earlier it was neutral, is brought near charge 2. So now the situation is that 3 is charged to a certain extent and it is now brought near charge 2. So it is touched with charge 2. So the question is, once this happens, that is a neutral sphere 3 is first touched to charge 1, and then after that this charged sphere 3 is touched with charge 2. So there's an obvious redistribution of charges, and the question is, what is now, after the redistribution of charges, what is now the force between charge 1 and charge 2? So let us say that the new force, electrostatic force between charge 1 and charge 2 is F dash, and this would obviously be minus F dash. So the question is actually first to find F dash and then tell what is the ratio of F dash to F. So let us examine, or let us understand how we'll approach this problem. So let us say this is charge number 1, this is charge number 2, and this is charge number 3. Now initially the charge on 1 is Q, the charge on 2 is also Q, but the charge on 3 is 0. Now charge 3 is brought near charge Q1, or rather the neutral sphere 3 is brought near charge 1. So there will be a redistribution of charges which would kind of transfer enough charge from charge 1 to sphere 3 so that both 1 and 3 have equal charges. In that case, what will happen is Q plus 0 divided by 2 would give a charge Q by 2 to charge 1 and also Q by 2 to charge 3. So there's a redistribution of charge Q between 1 and 3, while charge 2 remains Q. Now what happens is we bring this sphere 3 which has a charge Q by 2 near charge 2 which has a charge Q, and again there will be a redistribution so that both sphere 2 and sphere 3 have equal charges. So basically Q plus Q by 2 will get redistributed so that the final charge on charge 2 and charge 3 is nothing but Q plus Q by 2 divided by whole thing divided by 2, so that you get 3Q by 4 here and 3Q by 4 here, because the sum of Q and Q by 2 is 3 by 2Q, and if you further divide it by 2 it becomes 3 by 4Q. So the final situation is that the charge on 1 remains Q by 2, charge on sphere 2 becomes 3Q by 4, and charge on sphere 3 becomes 3Q by 4. So earlier we can say that the force between charge 1 and 2 could have been given as, or rather the magnitude of it would have been given as K into Q upon R square. Let's assume that the distance between them is R, which equals KQ square upon R square. But then F dash after the redistribution of charges can be given as K into Q by 2 into 3Q by 4, which then equals K times 3 by 8Q squared. So you can see that the new force F dash after the redistribution of charges between 1 and 2, F dash is now 3 by 8 of Q squared. So we can say that the ratio of F dash upon F equals K times 3 by 8 Q square upon R square, because the distance remains the same. And let me put R square here also, which I've missed. This becomes R square, and this whole thing divided by F, which is nothing but K Q square upon R square. So you can see that this term cancels, this cancels, and the ratio between F dash upon F becomes 3 upon 8, or F dash is equal to 3/8 of F. So the redistribution of charges has actually reduced the force between charge 1 and 2 to 3/8 of what it was earlier.